Everyone, my name is Nguyê Thi Lan Anh. Today I will discuss about how to teach the lesson moments of force and principle of moment. At first, we come into part 1 about context. First, about prior knowledge. Before the lesson, students about the principle of two line parallel force and about experience. Students are familiar with using the equipment like dynamometer and the method to investigate the resultant force. It's about context. Is part 2 about the goal of lesson. First, about knowledge. About knowledge have 2 points. First point is concept of moment force. Torque is characterized for turning effects and is defined as M equal F multiplied D, with D is level arm. And about principle of moment or condition equilibrium of a rigid object. The second is about inquiry skill. Skills which we expect students can practice over the lesson. Is 3 skills. First is formulate a tentative answer to the question. 2 is manipulate software or an apparatus to set up and execute experiment. Third is determine qualitative and quantitative relationship. And this is part 2 goal of the lesson. We move to part 3 is teaching and learning. This have a three phase. First phase is eliciting problem. We have a situation like we have the doors, and when we use the M to pull the door in the different direction, we have a turning effect is also direction. And we have some comments when the pull the door with the line of force is parallel or go through the door hinges, the door doesn't rotate. And when the pull the door with the line of force is perpendicular to the door hinge, the door always rotates. And one more is when the pull stronger and the distance to the door hinge is larger, the door open faster and easier. So we see that force is not characterized for turning effect. So we need a new quantity. So it is important to have a inquiry question is which factor does turning effect depend on and how it is dependent, and which is condition equilibrium for of a rigid object about a fixed axis. So students can give a hypothesized proposal like turning effects is directly proportional to product of F multiplied D. So it's about hypothesized proposal. And to check evaluating the proposal, student can say if you keep D is unchanged and F increased by 3 times, the turning effect increased by 3 times. But we don't have any equipment to measure the turning effect, so we deduce to consequences. Thus, this experiment to investigate the condition equipment of a rigid line F1 D1. equal F2 D2 in order to build the concept of moment and derive the principle of moment. And we turn to design the experiment. In experiment, the two variable is magnitude of force F and the distance D is change and measure. First, student can design the experimental setup like this. We have a plastic disc which has a small hole on concentric circle, and it is attached on the iron bolt like this, and the disc is rotated about a fixed axis is go through the center of the disc. And to measure the distance D, we have a ruler like this, and we can hang some mass to make a force F1, F2, F3. So about process of experiment. First, we hang mass on one side of the disc to make a F1. We have F1, and we see the disc rotate counterclockwise. And second, we keep the F1 and hang mass on another side of the disc. We have a F2, and we see F2 makes the disc rotate clockwise. So, and after that we see the disc is in equilibrium, and we see so to the disc in equilibrium, the resultant force of two right parallel force will go through the axis and apply the principle of two right parallel force. We have F1 over F2 equal D1 D2 over D1. So F1 D1 equal F2 D2 here. And students do experiment many times, and we have a table. It's 1, 2, 3 is F1, F2, D1, D2, F1, D1, F2, D2. Over the process of experiment, students see that F1, D1 equal F2, D2. But it is in the case of two right parallel force. But in the case of two concurrent force, what do we do? Student can change the direction of the F2 by a pulley, like this. And they do experiment, and we see that in the case of two concurrent force, F1 D1 even equal F2 D2, and we see F1 D1 makes the disc rotate counterclockwise. F2 D2 make the disc rotate clockwise. So to the disc in equilibrium, when the total turning effect makes the disc rotate counterclockwise equal the total turning effect makes the make the disc rotate clockwise. And this is condition equilibrium. And we see here is F multiplied D, here is F multiplied D. So FD is a characteristic for the turning effect, and we call FD equal M equal FD, with D is lever arm. And we do experiment many times with other case acting 3 force, 4 force to realize conclusion about principle of moments. is total moment, total counter clockwise moment equal total clockwise moment. This is all of my teaching.
So some manipulation skills with experiment. If there's two concurrent forces, for example, the pen will stop and analyze the equilibriums condition there.
Okay. So first in in process to experiment we see when you act a force in the science, this force rotate counterclockwise, and when we act another force in another side, we have this rotate clockwise, and after that this in equilibrium. So we have is F1, F2, we have D1 is D2, and we measure D is in the ruler.
Okay. And how about case of two concurrent force?
Case of two concurrent force is a pulleys will will have the mass of F2 over pulleys. Yeah. It's easy to determine the distance D. The line of force should be tangent with the circles.
Can you adjust this? Adjust to that case?
Here in that case, D equal 5 centimeters.
How do you know that?
Yeah, we can see that the line force is tangent with the circle, with distance from the center to the circle is 5 centimeters.
And how about the vertical force?
Vertical.
What is the lever arm of that?
Vertical. Here is a here is about 5 centimeters, because we can see that is the force one has a hang one mass, and F2 has a one mass, so D1 equal D2.
Sorry, I do not know this. How would you define the lever arm D1? How would you define it?
Here we can see it's a line of the force.
Okay.
And this is a line go through the center of the disc. This is a axis, so the perpendicular distance to line is a disc.
Okay, so there is a ruler below to measure.
Ruler.
I still do not get the point. So how do you measure D1? So which tool you use?
We can see the line of the line go through the central force, go through the 0 points.
Yes.
So the line of force go through the 5 points. So distance is 5 centimeters.
And how do you measure D2?
D2. D2, we can see the line of force of F2 is tangent with the circle 5. So the distance from the center to the circle is 5.
We cannot less in this case.
Yeah. So you say the 5th, not the 6th. So we count, say from here, 1, 2, 3, 4, 5. And this is the tangents of these circles, not the circles, the next one.
Yeah.
And I'm not convinced, you see.
Yeah.
Okay, so If I was used, I can handle the case as the direction of the true force are the tangents of one of the circle here. So, and I think it's the most convenient for students to see, to read the lever arm. And because you are doing the demonstration experiment, so it should be easy to observe the distance. In this case, you have to use the ruler, but the ruler is small. And over there, you do not tell what does it mean by D in the formula, so that kind of missing things.
Yeah.
Can you use ruler? Can you use ruler for math D2?
E2 because the radius of radius.
No, I mean you can use ruler, ruler for math D2.
Can you measure D2 by using the ruler?
D2 by using the ruler.
Using the ruler below. You know,
Yeah.
the ruler below can rotate also around the phase axis. Can you use that to measure the D2?
Yeah.
Okay.
Okay, so we have no time. Thank you.
Thank you.
No, I have the question. Yeah. Can you tell me again what is problem here, or what is going on here for people or students?
What is situation?
Problem. Yeah.
Situation is about the doors. When you use M to pull the door in the different direction, then the turning effect is also different. And we have some comment which will pull the door with the line of force is parallel and go through the door hanger. The door doesn't rotate. And when the pull the door with the line of force perpendicular to the door hanger, the door is also rotates. And
what is going on? What is the problem?
And one more is when you pull the door stronger, and the distance from the door hanger to the point of force we pull is larger. The door can rotate easier and faster, and so student can see turning effect is depends on the magnitude of force and the distance d.
So what is the questions?
Question.
Research questions.
Question is
You say all. You say and everything is clear. No problem for students.
I mean.
What would it be a conflict between novice student and new novice?
I mean that over the situation, student can see F is not characterized for turning effect, so you need a new quantity.
That I want to see this. I want the student can see this. But when you say alle, you say all. You say everything.
I mean.
There is no completion. Yeah. You must concentrate or focus on completion between previous novice and new novice.
So that way you can engage students in investigating further.
Yeah.
If you explain everything clearly, okay, I understand.
I mean, this is my presentation, but in the lesson I will ask students to comment about this situation.
No, but also for the others, try to present something. What will you do to engage students in the situation? And the key tool to do it is questions.
Yeah.
So you have to solve a series of questions, and then that question also leads the student to the situation where they cannot use prior knowledge to answer the question, and they have to think.
Yeah.
Okay,
Yeah.
so also the others also try to present that way.
Even though you want to present the talk, you can use that. You can make comparison between yourself by yourself. Yeah, you can say that we can put the door in
Direction.
this way or that way with the same form. This way the door can rotate. The other way the door cannot.
Okay.
Why? We have to learn that form is the cause or the cause of change movement. In this time, in this situation, form is speed kind of roadmap anymore.
Yeah.
Yeah.
So why? What is the problem here? You know, the two effects of force, one is to reshape things, and other is to cause motion. But in this case, I act the same magnitude of force, but that doesn't always work to rotate the door. So it means the magnitude of force is not represent for the turning effects of force. So what exactly the turning effects of force depends on? So the same thing you ask, but you find a good way to engage the student and also the audience, and think about yourself as a student. What should be in your mind when you are in the teacher's lessons and you are the teachers?
Yeah.
You don't need ask the student. If you say what you are thinking, you say what you are thinking. How have to yourself by yourself problem so no only topic much in this way, not simply speaking explaining. No, that's good.
So to be a good teacher, you also need to be a good storyteller.
Yeah.
Yeah.
Really. So.
And I have no other question. First one, only that one. I know that, but you have questions. It's okay. Which quantity is reason for cost benefit of this time, and how can you bring out took equals F1 D, not F1 L. You say yes, F1 D.
In the
lesson last use bring out.
Yeah.
So in this case, what students see is the distance between the fixed axis and the access points of the force.
Yeah.
And perpendicular distance is something more abstract, but that is the thing that the effect depends on. So how can you help students to realize that the turning effect depends on D, not on L?
Yeah.
And the same question is, why must you use this experiment? Why do you do it? Why do you need to do it?
Yes, I understand the question. In the lesson plan, I explain something, but in the presentation, I don't speak. First question is why is D not L? From the situation, the door when you act on the door one force in the one point, so the distance L from the point of force to the door hanger is constant. But if you pull the door with the line of force, with the direction is a different direction, which is with the constant force, which is the turning effect is different. But when in this F is not change, D is L is not change. So why turning effect is different? So student, so I
don't know.
I suggest students that the quantity change is the distance from the line of force to the door handle.
Okay, just tell him to student. And how? Why not you do it?
Yeah. Experiment. First, we need object can rotate to
what is the consequences you want to verify with the experiment? Tell shortly, one sentence, two sentences. What is consequences you want to test?
Consequences test is if you act too fast and too side is the object, we have a F1, we have a must verify that F1 D1 is F2 D2.
Then this is the answer for this your question. Your question answer is which quantity is present for the change of rotation.
Yes.
Now you answer other question. In which condition is one object balanced? It's other question.
I mean that turning effect is directly proportional to F multiplied D, and student get.
But this is the answer.
And student can rest that if you keep D constant, F is increase three times. Turning effect increase 3 times. But we don't have any equipment to measure the turning effect, so we have to deduce to the consequences that F1 D1 and F2 D2.
It seems okay, but it's
not very clear.
Okay, so you presume that the turning effect somehow depends on the magnitude of force and its directions. So you listen to the case that we acted two turning effects, but it's in opposite directions.
Yeah.
So if that two turning effects are equal, so I will make that this balance, although it is under the turning effect and the two force even.
Yeah.
Okay, and in order to get the balance of the two turning effects have to equal, and you assume that the turning effect is somehow depends on F times D. So you set up the case where F1 D1 equal to F2 D2.
Yeah.
And if you do that, you think because FD represents for the turning effect, and in this case you want to set up the case where the two turning effects are equal. So this is equal. So what we do observe is if this under our setting is equal or not. If they are equal, so somehow it checks our assumption that the turning effect is depends on the powers of F and D. Of course, there's still many more things, but at least you will have to say things like that. And for me, so English is not one of the best in the class.
Yeah.
So check with the video some pronunciation like turning effect, research questions, hypothesis. And the thing you write proposal is not a good term in this case. You can write assumption. I think it's a better term for.
Yeah.
Okay, you took too much time for us.
Thank you.
Okay.